Hey guys, so today, because I'm making this in the nights, video is going to be over moles and formula mass. So we're still working with compounds like we did before, and I showed you how to be able to write compounds. Now we're going to see how those are helpful when we're figuring out calculations. So we're going to get into moles and formula mass. Here we go. So the first thing I need you to do is define and remember what atomic mass is. So your atomic mass is going to be the number of grams, so weight, in 1 mole of an element. So again, the atomic mass is the number of grams, so how many atoms do you have in this compound or element in 1 mole of an element. And we've already talked about what a mole is. We will revisit that in a little bit. So again, your atomic mass is the number of grams in 1 mole of an element. So this number, as you know, is found on the periodic table. It's the one with the decimal, and it changes based on the element that we're talking about. So if we look at this tile, this is silicon, and silicon has an atomic mass of 28.086. Okay, so that's its atomic mass. So if I asked you how many grams were in 1 mole of silicon, you would tell me 28.1 grams, or 28.086 grams. Okay, so let's go back and remember what a mole is. I know we just did it, but let's do it again. So a mole is a unit of measurement, just like when we talk about a cup of water or a liter of water, or we talk about 6 pounds of sugar or a dozen eggs. It is just a measurement for chemistry, and it's called a mole. It's pretty much a count. We're expressing a value or a number or an amount of a substance. So why do we use it? Well, we use it because atoms are tiny, and when we have to talk about them, because they're so small, it equals out to be a really big number. Think of grains of sand. Like if I gave you a handful of sand and I said count it, you'd talk about hundreds, thousands, maybe even millions of grains of sand. So this number that we've come up with to describe moles is a constant, which means it never changes, and it's known as Avogadro's number. So what is Avogadro's number? It is, this came up wrong, but anyway, it is 6.02 times 10 to the 23 particles or moles. So let me rewrite that for you. Hold on one second. Let's find a good color. So it should be written as 6.02 times 10 to the 23. So like that. So write it like this and not like this. So again, what is Avogadro's number? It is 6.02 times 10 to the 23 particles. And how is it a constant and how is it related to the mole? It's a constant because it never changes. It's always the same. And it's related to a mole because 6.02 times 10 to the 23 particles is known as 1 mole of particles. So this number, or this number really, represents 1 mole. Right, let's move on. Okay, so what does this have to do with mass? Well, you have to remember that the mass of an object is directly related to how many particles is in that object and the size of each particle in it. So how much something weighs depends on how many things come together to make that one object and how big those things are. So let's look at this example. We have some examples of iron. In this one, it's 9 atoms. In this one, it's 8 atoms. In this one, it's also 8 atoms. Now, they all look different, but this one has the most atoms, so this would have the greatest mass because it has more parts and pieces. Okay? It's like trying to put books in your book bag. You might have small books and little books, but if you have 10 books, that's still going to weigh more than having 9 books, even if the book you removed was small, because you have more of it. All right, so Hopefully we're good with that. The more atoms you have, the more particles you have, the greater the mass of that particular sample. So again, what is the mass of a sample of substance related to? It's related to two things. The first thing is the number of particles and the size of each particle. So that's number 1 and 2 on your note sheet. The number of particles and the size of each particle. Right, now this example shows how size affects mass. So we have 3 samples. They all have 6 atoms, but notice that the K atoms, the potassium atoms, are the biggest, so they would have the most mass. Right, let's look at another one. So we have sample 1, which has 6. Now, since moles and number of particles are based on size, and they're also based on amount, they are extensive properties. Remember MVL men, where it's mass and volume and length and moles and energy and number of particles? So these are our extensive properties. So because different elements have different masses, chemists and scientists have had to study each element to determine how much mass 6.02 times 10 to the 23 atoms would actually be. So why have scientists had to study each individual element to determine their atomic mass? It is because we have different elements, and those elements have different masses. Don't forget, your atomic mass is the mass of 1 mole of that specific element. So if the element changes, the mass is going to change. So we have to study all of them. Okay, so now let's look at atoms and molecules and ionic compounds. We kind of touched on this last class. So the smallest particle of an element, as you know, is an atom. The smallest particle of a covalent compound, remember in covalent compounds we are sharing our electrons, would be a molecule. So a molecule is the smallest part of a covalent compound. Now ionic compounds, so these are the ones that are made by metals and nonmetals, and the metals give their electrons away. Ionic compounds take the form of something called a salt. Okay, so what structures do ionic compounds form? They form salts. Now, because they form salts, we call a single unit, and a salt is going to be, remember, it's going to be 2 things. It's going to be a metal and a nonmetal. So we call a single unit of that salt a formula unit. So what do we call the theoretical units of ionic compounds? Formula units. Let's go over those 3. The smallest particle of an element is an atom. The smallest particle of a covalent compound is a molecule. Ionic compounds make salts, and we call a single unit of a salt a formula unit. Now, you've already learned this. You know that every compound has a chemical formula, like H2O or CO2. In a covalent compound, the formula represents the ratio of atoms in each molecule. So, what's a formula? A formula is a ratio. How many atoms of whatever do we have? How many atoms of this? How many atoms of that? So what is a formula? Defined formula? It is a ratio. Okay? Now in an ionic compound, the formula is going to represent the ratio of atoms in a salt or in a crystal. So again, formula just means ratio of atoms. How many atoms do you have? So because compounds are made up of more than one type of element, to find the formula mass, so to find the mass of all of the elements in that formula, we are going to have to add the atomic masses of each individual element and then round up to 1 decimal place. So how do you find the formula mass of a compound? You add the atomic masses of all the elements in the compound and round up to 1 decimal place. So here's an example. In this example, we have NaCl. Na is sodium. When we look on our periodic table, we see that sodium is 22.990. Cl is chlorine. When we look on our periodic table, we see that it is 35.453. To find the formula mass, we would add 22.990 to 35.453, and we would end up with 58.4 after we've done our rounding. This would be the formula mass. The formula mass is measured in grams per mole because it is a measurement of how many grams are in 1 mole, so grams per mole. Now, what happens if there is more than one of a particular element in a formula? So like here is H2O, for example. So we have 2 hydrogens. Hydrogen is 1.008, that's its mass. Oxygen is 15.999, that's its mass. Because we have 2 hydrogens, we'd have to add hydrogen twice, or we could take the atomic mass and multiply by 2. It's up to you. So it would be 1.008 plus 1.008 plus 15.999, which is equal to 18 grams per mole. So again, if you have more than one of a particular element, you would add that element however many times you have it. So if you have it 3 times, you'll add the mass 3 times. If you have it 12 times, you will add the mass 12 times. All right, so here it is for you to write down. So if there's more than one of a particular element, you add the mass of that element however many times it appears in the formula. So like here, we have, again, this is water. We have 2 hydrogens, so we have hydrogen's mass once, and we have hydrogen's mass twice. And that gives us our overall answer. So just so that you know ahead of time, there are 7 elements, and you already kind of know this, that exist as what we call diatomic molecules. Diatomic means that they have 2 atoms, and they're going to be hydrogen, so H2, nitrogen, N2, oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, Br2, and iodine, I2. There are always going to be 2 of those with the molecule. So if we're looking at the formula mass for, sorry about that. So if you're finding the formula mass for oxygen, you have to remember that it's not just going to be 1 oxygen, it's always 2 oxygens because it is diatomic. All right, now we're done and we're going to do some practice. See you soon. Well, I'm already seeing you. I'll finish off in class. Bye.